Well, good morning. Hey, we're going to be discussing force and tension. Here's some of the equations we're going to be going over. Today, you're going to learn what tension is, what the normal is, how to calculate the amount of tension in a wire or rope, and then we're going to use vectors to understand the different directions forces are applied to an object. Tension. All right. What is tension? Tension is the force that a rope or cord is pulling with. It can be a wire cord. It can be several things. But tension is the force that is in that rope or in that cord. The normal force, the force that is acting perpendicular to the contact point. It points away from the surface. So the normal, what I want you to understand here with this is that the normal, as we've said, acts perpendicular. Waiting for my pins here to click on. We're dealing with a little bit of slow computer here this morning. There we go. And the normal here is going to be acting perpendicular. In this case, the normal acts perpendicular to the contact surface. All right, where the surface that it's in contact with. So when we make reference to the normal, we're going to be speaking uh, at a 90-degree angle. If it's something that's on the ground, the normal, we can calculate very easily the mass or the weight or the force of the normal. Actually, we should probably say the force, and it is the object's weight. Um, if an object weighs 100 newtons, then the normal is 100 newtons, except it's in the opposite direction of the weight. So the object's weight would be 100 newtons pushing down, but the normal would be 100 newtons pushing up. The normal is going to always act perpendicular. It's going to act opposite and equal in magnitude. That normal acts differently when on a slanted surface. We'll talk about that more here in just a very short bit. Um, I guess we'll go on here. Let's look at our first problem. All right, here's the first problem for today. If this sign weighs 240 newtons and the angle the rope makes with the bar is 55 degrees, how much is the tension in the rope? Well, I'm going to draw a free body diagram here. We haven't talked a whole lot about free body diagrams. Some of you have talked more about it in class, but we're going to give a little point right here. And we know the weight of the object. It's 240 newtons down. We know that the sign is in equilibrium, so there must be this resultant force that's pushing up or pulling up of 240 newtons. I'm going to call this negative because it's going down. So there has to be, for this to be in equilibrium, for it not to be moving, we know that they have to be equal and opposite. Well, I now know my y vector. It tells us the rope makes with the bar is a 55-degree angle. So this is a 55-degree angle right here. That means this one over here has to be a 35. So what I'm going to do is I'm going to take this part right here and I'm going to redraw it. I know that the upwards force is 240. I have this vector here, the rope actually, the cord, whatever's holding the sign, and this is a 35-degree angle. Well, this is very similar to what we've been doing, all right? This is the hypotenuse. This becomes opposite. This becomes adjacent. And what we do here then is we can say that the if I want to know, let me see here, how much is the tension of the rope? That's the hypotenuse here. Well, that's the adjacent and the hypotenuse. The adjacent and the hypotenuse. That is the cosine then of 35 degrees equals 240 over the hypotenuse. Well, as we've learned, we can simply interchange these two. We can switch the positions, and that becomes H equals 240 over cosine of 35 degrees. What that tells us then is the hypotenuse has a force, a resultant force acting on it of 292.9 newtons. Um, so you can see that this, even though the sine only weighs 240 newtons, this cord is feeling a tension or a force in it of 292.9 newtons. The reason that is that cord is pulling up. It's supplying all the force acting up, and we know that because if we disconnect the cord, the sine will fall. So it has to be applying a 240 newton force up, and it also is pulling some type of force in towards the wall. It's pulling it also towards the wall. So because it's the hypotenuse, it's going to be greater than just the weight that it's pulling. It's got to be greater than the y component or the x component. Well, at this time, that concludes our lesson on tension. I know there's not a whole lot of problem. Copy that one down if you want. It's a short little unit. It takes from what we've um, learned and expands upon it. We'll do some more work with tension here in a couple days, but I hope you enjoyed this. Be ready for some questions, and I will see you on the flip side.